Good morning, all of you. Is it audible? My voice is audible or not?
Yes, sir. Yes, sir.
Okay. Let's continue our class. Can you do the in the yesterday? Practical means can you practice the command in the Cisco router, in the Cisco packet tracer? Anyone? Can you answer me? Can you yesterday did you do the Cisco packet tracer? Jonathan, can you do the Cisco packet tracer yesterday?
So I was absent yesterday.
Hmm?
I was absent.
On leave.
Yeah.
Okay. Himal. Himal,
Yes, sir.
can you practice yesterday?
Sir, yesterday I went to MZQ.
Oh. Other you are still idle. Yesterday you are not doing anything. You are not doing yesterday.
Yes, sir.
That's not good. You have to practice those things. Okay. So let's move on to the last unit. Unit 4. Network administration of routing protocol concept. The first one, overview of routing protocol. What are the concept of the routing protocol and what is a routing protocol? We have to discuss today. The purpose of routing protocol is to learn of available routes that exist on the enterprise or a local area network or maybe company networks and make a routing decision. Some of the most common routing protocol includes the following routing protocol: RIP, IGRP, EIGRP, and ISIS and BGP. Are the common routing protocol implemented in our entire network, from LAN to wide area network, from local switch to entire internet communication, maybe a corporate or maybe an enterprise or maybe a local area network or maybe a building. So these are the common routing protocol used in this different types of network. There are two primary routing protocol types, although many different routing protocol defined with those type: link state and distance vector comprise the primary type. Okay, based on this two protocol comprise the primary type, maybe a link state or maybe a distance vector. Okay, these two routing protocol types are very important in the local area network up to the internet network. Maybe uh, one, or maybe the man, or maybe the gateway. Okay, and this link state and distance vector protocol is very important. Okay, let's see here. Internet gateway protocol is in this graphical representations in this picture. Let's see. Here we have internet gateway protocol. Within this cluster of network, we have a link of the routers. So each and every cluster of network, each and every clusters of routers interconnected using the extended gateway protocol or extended gateway routing protocols. Okay, so these are the thing in this routing protocol. Let's move on to the type of routing protocol, distance vector protocol. Distance vector protocol advertise their routing tables. Advertise means giving to another adjacent routers. So each exchange advertise their routing table to all directly connected neighbor at regular frequent intervals using a lot of bandwidth and are slow to convert. So what are the disadvantages of this vector protocol, distance vector protocol? This protocol advertise their routing tables. See in this figure, here we have the XYZ routers, router X, router Y, router G, and in between this router XYZ we have a connected link. Okay, we have a connected link. Each and every router having the routing tables. Okay, it's maintain the routing table like a switch. In our last class, we already explained that the switch device having the MAC address table for forwarding the Ethernet data frame. This Ethernet data frame contains the destination MAC address and the source MAC address and the preamble, frequency checksum, frame checksums. All those things are included in the frame data. Okay, data frame. Like this, in this routing table also, it's maintained the database. This is called the routing tables in the router. So here system X having a link to the adjacent routers. what is the adjacent router of this router X? The adjacent router is Y and Z. Okay, from this router X to reach router X, then there is no need of a distance vector. Okay, 0. And for reaching to this router X router Y, the distance vector is 1. Means from this X to this Y, the distance vector is 1. And from X to Z, then this is 5, then this is 5. The distance vector is 5 from X to Z, and so on. These are the table maintained by the routers with the distance vector of each and every adjacent router. When a router became available, all routers tables must be updated with new informations. So the disadvantages, the limitation of the distance vector protocol is that at a regular frequency interval, maybe a milliseconds or maybe a nanoseconds or maybe a 30 seconds or maybe a 90 seconds, each and every interval of time, using a double of time, share their routing tables. Okay, share their routing tables, and it consumes lots of bandwidth and are slow to converge. It can slow down the network also. It exchanges the informations. Okay, all router tables must be updated with that new information. The problem in which each router having to advertise the new informations to its neighbors, it takes a long time for all routers to have a current accurate view of the network. Distance vector protocol use fixed length subnet masks which are not scalable. So it's not scalable. It's having a fixed length of the subnetwork in the distance vectors, and it's exchange all the routing table to each and every adjacent routers. Okay, these are the thing under the distance vectors. So in this distance vector, the distance between the parent routers, the main router to the neighbor router, okay, from router to neighbor router, it's give the weight. Okay, this means that the vector distance number. So this vector distance number classify that the distance between the routing, the distance between the routers. Okay, let's move on to the next slide. Overview of this routing protocol, link state. Link state protocols advertise routing updates only when they occur, which uses bandwidth more effectively. It's very clear that it's exchange the information, it advertise the routing informations, routing table only when they occur, which uses bandwidth more effectively. when it is needed to update, it's update the informations. If there are some changes in the network, then it's update the routing tables, then it shares to other adjacent network. So this link state protocol use the bandwidth more effectively, efficiently as compared to the distance vector routing protocol. Routers does not advertise sorry does not advertise the routing tables which make convergence further. The routing protocol will float the network with link state advertisements to all neighbor routers per area in an attempt to coverage the network converge the network with new route informations. The incremental change is all that is advertised to all router as a multicast LSA update. They use variable length subnet marks which are scalable and use advertising more efficiently. So it's incremental change in all that it advertised to all router as a multicast LSA update. This update is based on the multicast, not in the broadcast. In the distance vector, it broadcasts all those informations in some interval of time. So it's consumed lots of bandwidth. It's not efficient and also not effectively use the bandwidth. But here, instead of using this broadcast to all the network, it multicasts to some point of the network, maybe a unicast or maybe a broadcast. So it's used alternatively. So this link state is more efficient, the bandwidth effectively. Okay, so here let's see in the graphical representation of this link state protocol. In this link state protocol in the IP version for IGP, we have this OSPF, popular standard based routing protocol, and another thing is the ISIS, popular in the provider network. Okay, provider network means ISP or maybe some network provider. It's used in this ISIS. Okay, before this, let's see this IGP in Internet Gateway Routing Protocol, or interior, we can say interior gateway protocol. And I make a mistake in the last in this topic. This is not extended. Okay, exterior and interior. Okay, interior gateway protocol and exterior gateway protocol. Okay, interior is the internal routing network communications, and exterior gateway routing protocol means it's communicate with the clusters of IGP, interior gateway protocol. So this Interior Gateway Protocol is a distance vector routing protocol developed by Cisco system by routing multiple protocol across small and medium-sized Cisco network. Okay, this IGP or IGRP developed by the Cisco system by routing multiple protocol across the medium-sized Cisco networks means interior. Okay, this small cluster of network. And also it uses this distance vector routing. The network cluster is very small, and also it's very easy to implement those things, and also it does not congest the network. Then it's used this distance vector routing protocol. It is proprietary, which require that Cisco requires that you use this Cisco router. This contrasts with IP RIP routing information protocol and IPX routing information protocol RIP, which are designed for multi-vendor network. IGRP will route IP and IPX in the NetNets or the AppleTalk. These are the network or tools developed by this or Apple company, which make it very versatile for clients running many different protocols. It is somewhat more scalable, and RIP, since it supports a hop count of 100, also advertise every 90 seconds. Advertise the routing tables in every 90 seconds in the interval of time. 90 seconds interval of times it advertises the routing tables and uses the composite of 5 different metrics to select the best path distance. Okay. 5 different metrics. There are different types of the metrics calculations, and based on these calculations, and it support the 100 hop count. Hop counts means how many routers it passes through the device. It supports 100 hop count. Then beyond this, it remove the packets. Okay, and it advertise the routing tables in every 90 seconds, and 5 different metrics to select the best part to have the distance vectors. Okay, to have the distance vector, the shortest part. Okay, in this exterior gateway protocol, we have interconnections with this interior gateway protocol, and let's move on to the OSPF. This exterior internet gateway protocol, let me go on to this one. In this EIGRP enhanced interior gateway protocol, gateway routing protocols, enhance IGRP, enhanced interior gateway routing protocol is a hybrid routing protocol developed by the Cisco itself for routing many protocol across the enterprise or company, or maybe buildings, or maybe different types of large network. It has characterized of both distance vector routing protocol and link state protocols. So it's characterized both the distance vector and link state routing protocol. It is proprietary, which requires that use Cisco routers. EIGRP will route the same protocol that IGRP routes, okay, and use the same composite matrix of IGRP to select the best path destination. Okay, this enhanced interior gateway routing protocol will route the same protocol that interior gateway routing protocol routes, okay, and use the same composite matrix. So it's use the same composite matrix used by the distance vectors, okay. Composite matrix as IGRP to select the best path. So IGRP select the best path using the composite matrix. Okay, 5 composite matrix for selecting the best path. Okay, let's see here. The option to load balance traffic across equal or unequal matrix cost path. Summarizations is automatic at a network class address. However, it can be configured to summarize at the subnet boundary as well. Redirections by the IGRP and EIGRP is automatic as well. There is support for a hop count of 255 and variable length subnet marks. So EIGRP is automatic as well as the it is a hop count of 255. In the IGRP is having the 100 hop counts. It can be 100 hop counts and also a fixed length of the segment marks. But in this extended interior gateway routing protocol supports a hop count of the 255. Okay. It can go across up to the 255 routers. Beyond this, router cannot manage. The hop count is excess. So if it's come more and more the hop count, then it's create lots of congestion in the network. There are lots of duplicacy in travel between the routers. Okay, packet travel across the entire router networks without hop count limit. That is create the congestion in the network. But if it's maintain the hop count limit, then if it's cause this hop count limit, then it's remove the packet by the routers. Okay, these are the thing in this IGRP and EIGRP. And what is OSPF? Open shortest path first. OSPF is a true link state protocol developed by Open Standard for routing IP across large vendor network. So this is the first true link state routing protocol. Open source is first part, and also developed by this Open Standard for routing IP across the large multi vendor network. a link state protocol will send link state advertisements to all connected neighbors of the same area to communicate route information. So in this link state, it advertises to all the network neighbor from the parent, from my routers, you can say, to all the neighbors at the same area to communicate routing informations. So it's to communicate, it is used to communicate the routing informations. Each OSPF enabled routers when start will send hello packet to all directly connected OSPF routers. So you send out first, instead of directly exchanging, or instead of directly forwarding the routing table in a broadcast mode or a multicast mode, there are some negotiations with the neighbor routers. Yeah. This is called the hello packet. Okay. It's send out the hello packet to all directly connected OSP routers. The hello packet contains information such as router timer, router ID, and subnet marks. If the routers agreed to or agreed on the informations, they come of OSPF neighbors. Once routers become neighbor routers, they establish adjacencies. So these hello packets send out such informations like router timer, what are the timing of the routers, and the router ID and the subnetwork of this router ID, everything. Then the neighbor computers receive this hello packet and analyze it. If the router agreed on the neighbor router agreed on the informations, they come from this sender OSPF router neighbor. Once router become neighbor, then establish adjacencies by exchanging the link state database. So after some negotiations and agreement between the router and the neighbor routers, then it's exchanged the link state database. It's exchanged the link state database. Routers on point-to-point or point-to-multipoint links, these are specified with the OSPF interface type settings. Automatically established adjacencies. It's automatically established a point-to-point or a point-to-a-multipoint establishment. Okay, establishment. OSPF with router with the OSPF interface configured as broadcast Ethernet and frame relay in the NBMA. We use designated routers and establish those adjacencies. Okay, this is the things in the OSPF. In the OSPF. And okay, that's all for today. Tomorrow we'll afternoon we'll continue the lab class afternoon. Then we'll continue in the next class of the next topics, that how to connect the static routers, connected routers, static routers, extended ping, and all this. Okay, so
nagtuka Friday ganito sa Thursday ganito.
sorry, or tomorrow is a holiday. Okay, tomorrow is a holiday. So we'll decide with the coordinator. Uh, Maybe we can have a test or not. I'm not sure. Okay, we'll give you the information again. Okay.
Okay, sir.
Okay. Okay. Afternoon. One at 1 p.m. Let's try to have some uh, review of this switch router, Cisco router switch, and how we are going to give the command. All these things we'll do it in afternoon class. Okay, that's all for today. Let me call your roll number.